Okay, we are in electrical rate. That is the third unit rate, all right, the electrical system. Okay, we're going to talk about current. Well, current, remember, is the number of electrons that are flowing through a wire, all right, and you must have a conductor, which means that the electrons can flow through it. All right, and you must have a continuous path, and you must have a voltage difference. Voltage difference just means that you have to have a change in the voltage in an outlet in your house. All right, there is no voltage difference until you plug something in. The equation, this is an old one, current equals charge per time. That's an important one to remember. All right, again, current is I, charge is Q, and T is time. The units are kind of English and SI. They're one and the same for when it comes to electricity. Amps for current, coulombs for charge, and second for time. And then don't forget that an ampere is a coulomb per second. And remember, coulomb is like a pack of electrons. There's so many of them. We have to actually package them up. And we package them as 6.25 times 10 to the 18th electrons. That's a coulomb. Okay? All right. Now, with technology today, all right, they use meters. All right, and they have what they call a volt, ohm, and milliampere meter. That means they're going to be measuring all three of those things. They're the most important things to measure. And if you were hooking them up, this is just something extra here. If you hook the voltmeter up, it would have to be in parallel. An ammeter, which is for current, would have to be in series of the circuit. It's easy to do voltage, not as easy sometimes to do the current. All right, we're going to be talking about frequency, period, voltage, and amplitude here today, specifically with an oscilloscope. I'm going to go over some terms they may not be so familiar with, might be like, what is she talking about? Wait until we get into some examples and they'll make a lot more sense. Frequency is a number of cycles per time. And the equation that they write that down is F equals N divided by T. F is your frequency. It's usually a small f. It could be printed or cursive depending on what book you're looking at. N is number of cycles and T is time. All right. Now, frequency, and you're going to hear another term, period. They are the inverse of each other. That's what they're trying to show you here. So, basically, if you had a period was 5 seconds, your frequency would be 1 over 5. All right, and the same thing is true for period. If the period was, let's say, 3 seconds, your frequency, well, it would be 1 over 3. Okay, we just talked about that already. Want to show you some, this is a transverse wave. I want to show you some parts to it. Top of the wave is called a crest. Bottom of the wave is called a trough. From point on a wave to the same point on the next wave is called a wavelength. Very important to remember that one. Wavelength from here to here. You could go from here to here would be a wavelength. Now if you were cut this right down the middle, all right, so you got a top half and a bottom half. From that line from here to here is called the amplitude. But you also have an amplitude from here to here. All right, now they should be the same because you cut it in half. All right, amplitude and the height of the wave, the importance of that is it's really equivalent to energy. If you are listening to the radio and you turn up the volume, essentially what you're doing is you are making this wave taller. It does not change its frequency. It does not change its wavelength. So that's why the sound should not be distorted. All right, they sound, if the artists that you're listening to, they should sound the same whether they're soft or whether they're loud. All right, so changing the voltage is what you're doing here, changing, and which is equivalent to energy when it comes to a wave. Here are the terms that I just talked about. Just going back for a second, I forgot frequency. Frequency would be the number of waves that you get, usually like in a second. So if we were to mark off a second from here to here, we got 1 wavelength, 2 wavelengths, 3 wavelengths, 4. So our frequency would be 4 cycles or wavelengths per second. All right, so it'd be like I said, 4 cycles per second. And then the period is the inverse of that. It would be 1/4. Okay, and that's how it works. Here's some other waves that you can see on an oscilloscope. This is called a square wave. When you actually see it, though, you don't see these vertical lines on the oscilloscope. You just see the horizontal lines. This is called a triangular wave, and you can see there because they're triangular. Sawtooth wave, you'll notice that you've got one that is perpendicular to that midline, and the other one is at an angle. And this one is called a sine wave. That's what we were looking at in the previous picture. This is a picture of an oscilloscope, and here's your screen. Notice that it looks like it has graph paper on it. All right, that's built right into the screen, and here we have a wave being traced out. All right, it's a sine wave, and you have buttons over here. These two here, you have, this is what's called a 2-channel oscilloscope that you could actually put in 2 different waves. Similar to like what you would do if you worked for a TV station. You would want the picture and the audio to match up. So you'd need 2 channels. Alright, so that one wave would actually overlap another. Alright, so anyway, this one here is going to be determining your voltage. Alright, for the first channel, that's voltage for the second channel. And this one is going to be the time. And the time has to be the same for both. Okay, so over here for voltage, you will have various units, but one of them is a volt. Okay, could be like what this one does is it does the vertical positioning, and what happens here is like it'll this little knob has a little marking on it, and it'll show you how many volts. So like let's say if it were 2 volts per division, and we've got, if you look at this wave, all right, from top to bottom, see where the trough is there, it's 2 boxes high. That means that if this were, let's say, 5 volts per division, it would be 10 volts. All right, you got 5 and 5, so that would be 10. Now over here we have our time. Let's say it's in seconds. What you would do is you are measuring a wavelength. Okay, so let's just say that it was 1 second per division. And you count them, alright, so let's see what we have here. It's an easy way. I usually look to see where my lines are crossing. So here it looks like this is a good one. So that would be 1 box, 2, 3, 4, 5. So that means that the period of this would be 5 seconds. Okay, remember what I said, it was 1 second per box. You got 5 boxes. Alright, so it would be 5 seconds. Your frequency would be the inverse of that. It would be 1/5. Alright, and actually the unit you use for frequency would be hertz, H-E-R-T-Z. Okay? Okay, let's go on to a couple other things here. Forgot to tell you about amplitude. The voltage, remember we said that it was 10. You just take half of that. It would be 5 volts. Alright, and we talked about period, and we talked about frequency. Alright, the one thing that you do have to be careful of is when, especially with the time, it's not always in seconds. I mean, some of them are coming pretty fast. So some of them are in milliseconds. And what you want to do is you want to move the decimal 3 places to the left. An example would be you have 12 milliseconds. So what you do, you assume the decimal's right here. And what you do is you count 3. 1, 2, 3. Alright, get rid of the milli, and you're left with 0.012 seconds. In the next one, you have 24 microseconds. Okay, micro. This funny looking thing here is a Greek letter called mu, and it stands for micro. Alright, you're going to be moving the decimal 6 places to the left. So again, you would assume that the decimal is right here, okay, on the right hand side of the number, 24, and you were going to count 6 places over. Alright, so that's what you get. Alright, ignore right here and right here, because this is where, knowledge is powerful, but when people don't do it right, it can be danger. Okay, basically what we have here is we're going to look at our voltage first. Okay, and we have, if you count these, you should have 8 boxes. All right, 8 boxes high. All right, from the top here to the bottom here. Okay, and if those boxes were set at 2 volts per box, or division, you'd have 16 volts. You want amplitude, you take half of 16, and it's going to be 8. Makes sense because it's cut in half. Okay, for the period, alright, they're taking the period from here to here, and they're telling us that it's 16 boxes. Alright, well, each box is 1 millisecond per division. Okay, so that's where we had to move our decimal 1, 2, 3 places. Alright, when you multiply those together, you get 0.016 seconds. Alright, and then to find your frequency, what you're going to do is you're just going to take the inverse of that, 1 divided that by that 0.016 seconds, and it gives you 62.5 hertz. That's the main things that you are going to need to find on an oscilloscope. Okay, here's our next wave. Okay, let's just take a look here. We have 1, 2, 3, 4 boxes. If each box is 0.5 volts per box, that means that we have 2 volts. Alright, so from the whole thing is 2 volts. That's our voltage. The amplitude is going to be half of that, so it's going to be 1 volt from here to here. The period is going to be 2 boxes. It's going to be from here to here, so we basically would count from the halfway mark to the halfway mark here. There's 1, 2 boxes. Okay, the one nice thing I like about actually using a real oscilloscope is you actually can move this wave so that the top of the crest is right over a vertical line, and then it makes it easier. But well, we'll make do. We're smart enough to make do here. Okay, and then when you're finding the period, it's going to be 2 boxes, and if it were 0.0005 seconds per box, then you'd find that the period is 0.001 seconds. To take the frequency, you're going to take the inverse of that, which means 1 divided by that number. Alright, and when you do that, this is what's amazing, it becomes 1000 hertz. A lot of times kids are expecting really small numbers there, and you don't get it with this one. Alright, well that wraps up for dealing with rate and primarily dealing with using the oscilloscope. You might need to go over this section a couple of times. It takes a little bit to get used to. There's a lot there when talking about the oscilloscope, and have a good week.